Boom. Yeah, we're good. Alright. Hi, I'm Tom Marks. I talk about code today. We are going to be continuing our PlayStation 2 dungeon crawler-like game. Still porting some code across from my Lisp Game Jam entry. We're still going to be using that as our basis. Today, well last time, and it's probably a good idea to start these streams off by showing what we actually worked on last time. Let's do that really quickly. This is running in a Love2D wrapper that kind of emulates the PS2 APIs we're exposing from Lua. And we have a player that moves around and can do a little shooting attack, right? At the moment, there's no checking to make sure that we're pressing the button. We can just hold the button down and it'll continue to shoot. That's something we probably need to change. I made a few little tweaks to just kind of the numbers of the player movement off stream, I think. I think there was one commit called improve player movement or something of the sort. So the player just was a little bit snappier now. I made some changes about how friction was being applied. So that's good, that's in a good spot. This stream would be good to get player sprites working, and maybe actually doing animations, which is something that didn't make it into my Lisp Game Jam entry. The player was just always a fixed sprite. It'd be good to have them, you know, face the direction that you're moving. I did some fantastic programmer art, which I'll show in a minute, for the Game Jam. Most of it went unused. I've also got actual tile sprites. Again, would be good to actually start using those and to start, you know, putting together some environments, right, that kind of look like something. So if we jump over asset characters. So it's hard to see on this background, right? Because it's a grey character on a... Oh, that's not what I wanted. A grey character on a grey tiled background. I also think there is a keyboard shortcut to turn off filtering, or maybe it's a command line option. Manfair. Linear filter scale without repeat. No, that's not it. Scale. Okay, well I don't know how to do it, but the important thing is we've got some character images that we can use. I don't know what happened to my where are my tile sprites? They're not in here. Are they? Where did they? They're gone. They're gone. Well, that's annoying. I might have to actually like download the entry to get them back. I must have deleted them from the main repo, but not not reclaimed them anywhere. Okay, so let's go. Cool, but yeah, so if we want to get some sprites drawing again, right? The way we've got to approach this, it's a little bit different to how Love2D approaches it, for example, where you kind of give pixel coordinates. We're giving coordinates directly in terms of UVs, and we can see that in text.lua, right? When we draw our sprite, we give literal offsets, relative offsets in the range of 0 to 1 into a texture. So let's get a character texture back. That would be a good place to start today off, right? Doing something nice and visual, because the last stream was not very visually appealing, right? And with the state of things at the moment, it's not very visually appealing. So where do we load texture? We just want to copy this out. Let's say, let's call it the character texture. We'll grab it from characters. We're also going to go tile texture. Because we have a tile texture. Also, fun quirk of this system at the moment, fun limitation is that we have a fixed size for all of our resources. Unfortunate. So just in the background here, I'm hunting around. Here we go. Just downloading the package from itch.io, right? You know, boost my own stats a little, right? That's a good perk. Temp. Perfect. Oh, I deleted it from the release because it wasn't getting used. That's right. So it is in a commit somewhere. Okay, hold on. Let's delve down into this into the history of this project. So if I go to github.com, if I go to me, we go into assets, we go into fennel test. And I look in the commit history. So Lua, not the history, the list of commits, right? Where's the, how do you do this in GitHub? How do you, where's the log? Where's the, one parent. I guess we can just click through the parents manually. I don't know exactly when this got done. It'd be like, it'd be a little bit before here. Yeah, well, the level editor stuff is still here. So when I had a level editor working, I definitely had a tile map. If I go into asset, okay, it never got added to Git. Oh, well, look, I'm not missing much anyway. I might just have to do some new programmer art. Let's do exactly that. I wish I knew this before the stream started, but anyway, all my images have to be 256 by 64. That's a bizarre technical limitation, which, for various reasons I won't go into, let's just say it's complicated. We're working on a 16 by 16 grid. Let's go view show grid, and we're just gonna put some stuff down, right? We're not gonna think too much about it. We're mostly gonna go like gray blobs. Where? Oh, clipboard image, get out of here. I was doing some fun stuff. I've got a really good clickbait thumbnail coming up for the previous video. Hello? What have I done? Why? Oh, fade tapering. I want just like dynamics off, right? Dynamics off. And this down to 1. What a hassle, what a hassle. Okay, so let's have a tile that's like maybe a darker outline and then a fill. We'll start with that. And then maybe just have like 2 variants of it as well. So we'll have one that's like, maybe got like the cross. That's a classic tile map pattern, right? But then you need, you know, 2 of these to be like a slightly different shade. There. I mean, oh, I love this. This takes me back to my like Game Maker days. What else? What's another good variant of this like basic wall? I guess maybe kind of like a slightly cracked variant. But my idea is going to be, okay, with this layout, we're going to have, so this is going to be like tile 0, right? And then this is the variant of tile 0, this is another variant of tile 0, and this is, I might leave the last row for like special things. And then we have tile 1, tile 2, etc. But we'll space these tiles out, so each tile will have maybe like 10 variants or 12 variants. Each one of these individual cells will have, you know, 10 to 12 variants based on color. So, you know, this will be tile index. So 0 will be empty. This will be tile 1. Tile 2 will be this but recolored to red. Tile 3, so this is 1. 2 will be this recolored to red. 3 will be this recolored to blue, etc. Then this will be tile N, and then this will be tile like 2N, right? And then we'll go through the whole set like this. That's my kind of thought. I don't know if it's a good thought, but we'll find out. So let's. I figured the only way to find out is to like try it and see if it sucks. So yeah, we'll just like have some. That's yeah, maybe just like a slightly cracked variant. I don't know if this is actually good. Like I said, my programmer art is terrible, right? But you know, just have like a wall with a little bit of detail in it. Sometimes. So let's roll with this as our starting point for now. We'll save the raw file. Where are we? Workspace, PlayStation 2, Dungeon Crawl, asset, tiles.xcf. And then we're also going to export it as a TGA because TGAs are really easy to parse. No runtime compression, and it has to be top left. That's how we're reading them in. Okay, so if I run this now in a PlayStation 2 emulator, it hopefully won't crash, and it doesn't, so that's a good sign. We've loaded textures, we've got some TLB misses, so this is actually a problem, and this is going to be very, very dangerous, and I think this TLB miss might actually go away if we comment this out, I suspect. I think this is why I actually removed them originally, and yeah, so what that means is we're loading too much and something is overflowing somewhere into memory that it shouldn't be hitting. So that's kind of a big deal. It's kind of a big deal. So we have to make a decision. Do we want to do characters? Do we want to prioritize characters, or do we want to prioritize tiles? I'm going to prioritize tiles for now. I think that's going to actually give my game, ironically, more character while we get started here. Right? I think that's actually a more interesting thing to solve for now. And we get a TLB miss on it. Weird. So maybe it's actually the file. Because the same thing was happening with the previous when I was loading this before, host tiles.tga. It definitely knows it's there, and this is definitely a 256 by 64 pixel image. So why does it not like this file called called tiles.tga? So first off, there's a problem here. Dist tiles.tga does not exist. Dist. That would be because we haven't run make assets. So now if I run this, is it going to work? Weird. Okay, well that explains why that didn't work at least. Okay, but in engine asset, we now have tiles.tga. That's good. Hold on, where did I save this? Did I save this in the wrong spot? Dungeon core asset? No, okay. So there's a tiles.xcf here. I'm guessing that's the old tiles.xcf. What is going on? This is such a chaotic start to a stream. Cool. So we'll crack this. We'll crack this. If I head over to our make file and look at what we're doing when we make assets, cd make assets. Yeah, so I need to copy our assets across. Then I need to go make C engine assets. That is an easy fix. So now if I run this, we actually have tiles. Okay, cool. So now I go into where we're drawing at. Well, now I see if we can actually load everything without a TLB miss. And we can, so that's good. That means that we can actually do this on a real PlayStation 2 probably, although I do want to verify that pretty soon. But yeah, like all this console spam is all about the work that goes into building the packets to actually load the texture. That is good. And it also, our VRAM allocations are getting quite high, but I think we're okay. Okay, so if we go into where our tiles are drawn, and I believe this is in room.lua, draw tiles. So let's just change this now rather than just the normal rect. Let's say d2d sprite. It's gonna be at the same coordinates, I times grid, j times grid, 16, 16. But now we also need to give it the UV coordinate. So we'll start at 0, 0, and then 1 over 256. No, what am I doing? So 256 is 1 width, right? So I want it to be 16 over 256. So this is our normalized x coordinate. Python 16 over 250. I can do this in my head. That's okay. Well, I can't do that in my head. So the normalized x texture coordinate is 0.0625. And then we do the same thing for the y, except this is 64, and this is just a quarter, right? Yeah. Okay, so this will draw us a sprite rather than our quad. Oh, but the texture needs to get passed through here, and this is where we get a complication, right? Because we have a data flow question here. With our font, we just have like a really dumb global variable because fonts are quite dumb in their nature, right? Like we're only going to have one font. We have no fancy font logic. We can just set it in one place, and at a package level, we maintain that state. That's fine. But character and tile textures, where should the references to those textures live, right? Does the game manage them? Well, then how does the game pass it through to the room function, right? There's an interesting data flow question here. How do we pass these through to where they need to be? How do we make sure that a entity can reference this character texture? How do we make sure that the room can reference this tile texture? And I don't have a great answer to this, unfortunately. We do have this like global room state, so maybe actually this makes sense to live as part of this, but we're returning an anonymous an object that we can never like, yeah, an anonymous table here. So my thought is to copy what we were doing in fennel, which is to just have a dumb resources file, which also gave us utilities for building UV coordinates, and also gave us a convenient place to define a big dumb table of frames, right? So we can say, hey, you know, here are our player frames, rather than having the player actually have to work out whatever's going on. We just in a kind of high level way say resources, we want the player frames for when they face down, we're going to get the first frame of that, we're going to get the second frame of that, etc. So let's copy this. Let's go script. Okay, so local res, and we're going to have character texture. We're going to have a tile texture. We may have more character textures in the future. I'm not going to think too hard about how this scales for now. I'm just going to go with the everything fits into one texture dumb assumption. Because again, we actually have a limitation in our engine that we can't load textures after the game started. And we also don't have enough VRAM to load a whole bunch of different textures in. So until I implement mid-frame texture swapping in VRAM, which is how every PlayStation 2 handles drawing, you know, any kind of reasonable texture detail in a single frame, until that, we're pretty limited. So we're just gonna do the dumb thing. And actually, we're gonna call this nil, not empty table. I've been doing a little bit of Lisp in the last few days. And so in my mind, empty list and nil have been very equivalent, but they're very different things in Lua. Okay, so we've got characters, we've got tiles. We're going to have these like other random constants. So let's say res.player frames. I like this a lot. So this has like a down equals blah, left equals blah, right equals, and up equals. But we're not going to like think about that too hard for now. Then we're also going to have function res dot yeah, we'll export it uv xy to uv. So we'll take the image width, the image height, an x and a y coordinate, and we give back the calculation we did over here, right? So return. Can you do multiple returns in Lua? I think you can, right? I think I can just go IW, x divided by IW, y divided by IH. I think that works. We'll find out. Lua functions with multiple returns. Of course, it's a Stack Overflow. First thing, the function with your functions in order to see blah blah blah. Yeah, okay, I think that's good, right? I mean, stack-based languages, it's the easiest thing to implement. Cool. So, this... I did it as a rect here, and I think in general we're actually never going to do this as a single point, right? We're always going to be converting a rectangle into UVs. So every instance where we call this, we'll actually call it twice. So yeah, there maybe actually is some merit to x, y, width, height, and then we take the image width and the image height. I do actually quite like this. And we'll give it back in a structured way as well. X equals, or what is it? U1 equals x divided by IW. U2 equals x plus width divided by IW. Then the same thing for V1 with the y and the height. V2 equals y plus height divided by IH. Cool. And this name is actually a very different style to everything else we've used before. Let's call it 2UV instead. Perfect, perfect. Okay. And we'll define it up here because we're actually going to use it in other places. And then at the bottom of this file, we need to return res. Let's also do res.load textures, I guess. Just so that we take some of this out of main. Just so we take some of this out of main. Not that main. This main. Cool. Do we make this? Let's make this a method. It's good. Then we have self.character, self.tile. And then we just need to import draw2d. That's not how you import. Perfect, perfect. Okay. So now we go into main. We're gonna keep the font loading kind of separate for now, I guess. Res. Cool. Res load textures. If we go into now tiles is going to be kind of if we think about what this function actually does, if we call this for every tile we draw, if we're drawing like, you know, what, 20 by 30 tiles, that's well, 20 by 20 tiles is what, 4,000 tiles. So, you know, building a new table 4,000 times per frame kind of slow, so we're actually not gonna do quite that, but let's see what happens. Let's see what happens. Local resources equals require. If I run this, hopefully it won't crash. It does crash because this file is called resource, not resources, because I'm using singulars. That's good. Okay, that's where we want it to crash, because if we go back into room.lua, draw tiles, we need to pass something here, and this is going to be resource. Let's just call it r.tile. We'll call it r equals require. No semicolons, thank you. Cool. Okay, and you can see we're drawing a slightly shittier looking tile here. So let's actually, okay, so we want a version of this, I don't even know. I feel like for the tile map, we can actually get away with not touching the 2UV function. It's going to be a nice utility when we're like getting character sprites, but for the tiles, we kind of want something more specialized, I think. Or maybe not. Maybe we do just define this up front, right? So we go resource, we go res.tiles, res.tile UVs. Do we just go that simple? And then we have like a list within this. So we say, I guess, yeah, res.2uv 0, 0, 16, 16, 256, 64, right? So this is the tile we were talking about before, but then we also have a bunch of other things. And we can actually build this programmatically, right? So let's forget this. Let's say for I. Okay, what are we doing? We're gonna loop over every possible tile and enter. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 1, 2, 3. So 3 by 16, right? And we're gonna do vertical first and then horizontal. So for I equals 0, I less than 3, I plus 1, do. For j equals 0, j less than 16, j plus 1, do. 16, did I really say 16? 16, oh yeah, 16 squared is 256, of course. That makes a lot of sense. That's how base 16 works. Okay, so j, 0, etc. We're gonna go table.insert res.tile UVs. And we're gonna insert res.2UV. Okay, now. So it's gonna be I times grid. Yeah, j. No, it's gonna be j times grid, I times grid. 16, 16, 256, 64. Right? So this is gonna build in a specific order. So like 0, 1, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. This is gonna build that here. And then when we actually go, okay, well, yeah, that's fine. Vertical first, because this is how we're thinking. This is our model right now. Okay, so now in... God, if this could focus on the right window, please. If we go back into room, instead of all this, so let's say local t. So we want to, rather than just checking if it's greater than 0 and drawing something, we're now going to add a little bit of logic here. We're going to get the tile at ij if the tile is bigger than 0, right? 0 just means draw nothing. Okay, how many color variants do we want? Let's go for 5 color variants, I guess. So I guess for now, let's just skip drawing color. So what we're going to do, we're going to set our color to this magic number, which pretty much seems to be the middle of the road. And then we're going to divide our tile index. We're going to divide it by TT. We're going to divide it by 5 because there are going to be, yeah, 5 different color variants. That'll be good. That'll be good. This is going to look so, this is going to be so good once it works. And then we add the tile, add the coordinates, and then we need the UVs. So let's go r.tile UVs. UVs. We want to capitalize that. I think that's better style. Tile UVs. Okay, tile UVs, and we're gonna get the one at TI. Is this? But I think it has to be TI plus 1 because freaking Lua and math starts at 0, but oh no, but we start at 1. Actually, I think that works. So what happens if I run this now? Attempted to perform arithmetic on global grid, a nil value. Grid. That's because over here we don't actually have a grid, so let's go local grid equals 16. Again, we should probably define that globally somewhere so that we can change it. Okay, arithmetic value on up value u1, a new value. Okay. So u1, a nil value. Does that mean... So... Wait, hold on, where is this? Love draw 43. Oh, yeah. The love wrapper draws in a really creative way, which I won't go into because it's not really the point of what I'm doing here, but man, that it's going to complain about up values rather than anything else. So, oh yeah, hold on. What am I? I'm very tired today, apparently. Dot u1 r dot. Well, okay, I'm gonna get RSI if I type all this out. Local UVs equals r dot tile UVs ti. UVs dot u1 UVs dot v1 UVs dot u2 UVs dot v2. Okay, there we go. This time we got it. Not quite. UVs. This is a nil value. Okay, time for some debug printing. Make tile UV coordinates. We're gonna get j times grid I times grid hash res dot tile UVs. Right, so we'll say that we're putting these things in at this address, at this index, I guess. So what happens when we run this? The logging is kind of broken. Love. Okay, there we go. That's a little bit better. Is it? No. Well, let's run it in emulator because we actually get better logging there, or a more interactive log. Cool. So, index 1, index 2, index 3. This is what we want to see. Index 4. Wait, no, this isn't what we want to see. Wait. We want vertical first, not horizontal first. 1, 2, 3, 16, 17. Oh, we also want to stop short of this. Hold on, we're doing one too many here. There's no tile at this, there's no tile here, right? This is the end. This is like saying there's a tile that starts here, which is nonsense. There is not. That's out of bounds. Okay, that's cool. That's cool. So we're doing one too many here. 15. I think this is because Lua frickin' one indexed nonsense. Starting at 16. Yeah, okay. So I don't know why I moved that to that scene there. Okay. So now this goes to 1, this goes to 2, blah blah blah, and then we're doing one too many. Yep. Because again, Lua is 1 indexed and we're starting an iteration at 0. Okay, but when I run this, I'm not going to get a decent error out of PCSX2 here, unfortunately. I still get this index local UVs a nil value. So let's go back to room.lua, I guess, and print out... Oh, hold on. TT. This still shouldn't be a nil value, but it draws something now, which is good. And if we run this on the emulator, this should also work. That's good. That's good. I think this means we exported with run length encoding on somehow, right? Does that make sense? Export to tiles, export as tiles.tga, replace, no run length. Weird. Make assets. Let's just make sure. Also, just as a quick sanity test, let's go engine dist tiles.tga. Okay, so that looks correct. And yet when we run this... So we've got to check the values that get put in here, right? This is the next thing to check if this still looks like garbage. Okay, yeah, we got to check our UVs. We got to check our UVs. Let's go print UVs U1, UVs U2, UVs V1, UVs V2. Okay. This looks perfectly fine. This looks perfectly fine. 0, 0 to... Weird. Did I do them in the right order here? I did them in the right order here. Okay, so these are perfectly fine UVs. What if instead of this... Let's just quickly make sure that I'm passing these in the right order. X, Y, width, height, U1, V1, U2, V2. X, Y, width, height, yep. Okay. So. Could I be copying garbage into VRAM? Possibly. What's going wrong here? Let's try drawing this with dumber UVs. Let's go 0, 0, 1, 1, right? So if I run this in Love now, I get some interesting results. If I run this in the emulator, I should also get some interesting results. But I still get the same garbage. Okay. Something is going wrong. Something is very wrong with this image. Something's very wrong with this image. That's really odd. This was working before. I actually had this working. Sorry, I've got a face mask in my pocket. It's very uncomfortable. Alright. Okay, so it looks like it's kind of like the general shape is there, but the pixel ordering is very, very wrong. Let's go to where we initialize. Is it in main.lua? Do we initialize like the tiles here? Where are we? We do. Okay, so we'll just set one tile. Just one tile. So somehow we're striding through this texture wrong, right? Like it doesn't understand where these bits should be going. Because this one rectangle here, like first off, the red, green, and blue data is like weirdly spread out. So what have I done? What have I done differently? Because this worked before, right? Is it because, hold on. I've got a theory. If I add an alpha channel and then export it again, where are we? Tiles.tga. I've got a theory. I think the bit, it's treating it as 24-bit rather than 32-bit. That would make sense. That could explain it. So if I go make assets, which should run anyway, but we do it just to be safe. Yeah, there we go. Okay. That is very comforting. It was just a nice, silly, innocent mistake. Okay. So now if I come in, and so if I go back to main, back to where I just commented out some stuff. So I could go 4, 4 is 5, I think, and then 5, 5 is 10, and this might do something different. Yeah, okay. Not quite what I wanted, but because this is still doing X first, so we need to swap the order. That's right. It never ended up actually doing that. No, well. Oh yeah, of course. I just got my loops backwards. Easy mistake to make. So 1, 2, 3. We're dividing the index by 5, so this should still go to 1. So this should actually be 6, and this should be 11, right? No, wait, this still goes. So this is 0, 1, 2. 0, 1, 2. But these tiles get mapped to 1, 2, and 3. So, Also, I can test this in love now. Yeah, perfect. Okay, so 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. Draw room. So we get the tile. Again, we're just going to do some dumb logging, just some log-based debugging, because it's an easy way to get what we want to see. 1, 0, 6, 2, 11. So why does getting 0 here give us anything? Because we're grabbing index 0 of the table, right? We're just going... Like, why does this... What does this give us back? Why does this give us back what we want? This shouldn't, right? It shouldn't give us back what we want. This is wrong. This is wrong. Okay, what if I just say +1 here, because this, again, surely is actually the correct logic, right? We want this tile to map to this, which goes into, wait, but this says the table has 1 length. Is that before we actually write anything? That's after the insert, yeah, so, Thanks, Lua. Thanks, Lua. Alright, well, let's go back to not adding 1 and assume that indexing somewhere 0, 16. Okay, we're gonna do some more debug-based printing. We're gonna go draw tile TTTI, and then we're gonna go UVs.U1, UVs.U2, V1, UVs.V2. We are gonna do the dumbest log-based printing, if I can run it in the right thing. Really dumb log-based printing. Okay. Log-based debugging, I should say. These are the wrong indices. Why is this increased? Why is Huh? so we expect all of these to have so we're getting even what? So for each of these things the x coordinate is increasing, right? So this is correct. And this actually draws the tile we expect it to see. This is the correct y UV indexing, I think. Wait, is it? Wait. No, it should be this. These two are flipped for some reason. But this is wrong. This is wrong. Table.insert. This table insert has to be doing something weird, right? Let's go for I v in I pairs res.tile UVs. Print I v.uv1 v.u1 v.u2. V was a terrible choice of name for the loop variable here, but we'll be fine. Okay. For some reason, this is just behaving very oddly. Okay, so 1, 2, 3. Yes, that's very good. This is what we want. So then why, when we draw, does A, 0 give us anything meaningful, 2 not give us this, and 3 not give us... I'm grabbing the wrong thing. I'm surely grabbing the wrong thing. That has to be the answer, right? Yeah, I'm grabbing the undivided number. That makes so much more sense. So now when I run this, it's going to freak out because it's going to try and grab a table that's nil. So I have to add 1 onto this number. And actually, let's do that up here. So this line handles the mapping, and then this line actually just does the dereference, right? There's no logic in this line about the format of our image or anything like that. So now, there we go. We have 3 wonderful tiles being drawn, and this is also going to draw in our PS2 emulator. Okay, that was a lot of build up for not a lot, but there we go. Let's clean up some of this frickin' logging, because that is very, very noisy. And this can also go... It's amazing how when you stop doing the wrong thing, the right thing just starts happening, right? That's awesome. That's awesome. Cool. So you can see building some dungeons out of this. So let's add some quick color logic. I don't think it should take too long. So if this is this divided by 5, then our color index is going to be TT mod 5. +1, not +1. That's fine. So... if CI equals 0, then I hate this, but we'll live with it. So the base color variant is going to be just boring. Else, if CI equals 1, then... Actually, that's probably a better... Can I... Maybe I can, like, map this somehow, right? So let's go... Let's just get a nice big canvas. Think about this idea. Okay, so... Okay. So we've got index 0, 1, 2, 3, and 4. We want these to map into colors. So let's assume that 4 is going to be white. AKA, let's call it 1, 1, 1. Right, so red, green, and blue all at their maximum value. And let's say 0 is going to be black, or maybe something dark. Maybe let's say 0 0.1, 0 0.1, 0 0.1 maybe. And then 1, 2, and 3 are each going to be, so like 1 can be 1, 0 0.1, 0 0.1, right? And then 2 can be the equivalent, but with, yeah, so this should make the logic a little bit simpler, right? We can do something so that these numbers actually encode what they mean, like what this means for some colors, rather than just having a big if then else statement. Screw it, let's just have a big if then else statement for now. Let's go, so 1 is going to be red, I guess, but let's not make it like too garish of a red. Let's go like A maybe. CI equals 2, then CI equals 3, then 4. So for 4, let's do the like darker one. Let's go like 0x1, 0x1, or 0x1, 0x08, maybe 0x0e. And I set the alpha to 0x80 for, I don't know, it looks okay on the PlayStation 2. Apparently I can actually set that all the way up to FF, but when I do that, the color seems almost too intense on a PlayStation 2. I don't know, I need to play around with the texturing mode I'm using. I think I might be using, I think it's called like patch mode or something. There are a few, there's like a patch and a modulate, and I haven't worked out which ones look best. So this is going to be this, but with the color things in different orders, right? So this is going to be, green is going to be even less intense, I guess. Maybe a little bit more intense. Let's go CO. Just for fun, and then blue is going to be, what am I doing? Blue is going to be like, a little bit green and a little bit blue. So let's say maybe AO and then FO. So now if I run you, okay, they all get a red tint, which is cool. Let's go into main.lua. Let's just like build a little random patch. That might be good. So for I equals 1, maybe like a 20 by 20 patch. Oh, not 20. 20 is too many. Let's go 10 by 10 patch, right? So we'll just set ij to a random thing. For now, let's see what happens when we just like set it. Yeah, cool. Nice boring patch. Lua random number. I think it's just random, right? Or math.random. Math.random seed. Cool, so if I'm doing this, it should be 0, 1, 2, 0, 1, 2. So it should go up to 14, right? So 0 to 14, or 1 to 14. Yeah, does that make sense? 1 to 14. So times 14. Or times 15 minus 1, right? So if I run u, bad argument to random seed, expected something, let's make it a fixed seed, then it's always going to be the same. 2, a nil value. Oh, I override math.random, don't I? PS2, or is that in main. Yeah, I override it. Okay. I need to make this more flexible, but we'll get a random number from 1 to 14. It's taken care of for us. It's taken care of for us. But we have to floor it as well. Okay. I think we actually then want 1 to 15, right? 1 to 15 floored, because this will never give us back 15, and so we floor and it gives us the range 1 to 14. Now if I run u, yeah, look at this. Oh, we get some colors, we get some things that don't belong. This apparently gives us things below 1, which is a little bit weird. Okay, this is not working for me. This is not working for me. Random. Let's use the like captured base version of this that I have 15 minus 1 plus 1. Let's see how it looks on the PlayStation 2. Oh, and that chugs our FPS a little. This tile drawer is very inefficient because we're building this entire draw list in Lua, which is a bit unfortunate. I need to make a better version of this. But yeah, like you can see, we get a couple of different colored tiles. I think that's a cool encoding of what we've got. The dark, these aren't black. These are just dark versions of the tiles. That's fine. And then we have a few things that are like leaking out. So I think that's actually one too high. If we go down to 14, this should stop doing that. But maybe not. Yeah, there we go. Perfect. And if we actually swap this over to Love 2D, we expect to see exactly the same tiles because we've got a fixed seed. Nice. And this one actually, funnily enough, does not tank the CPU because Love 2D does sensible rendering. Perfect. Okay, so we can draw arbitrary tile maps. That's really cool. I need a way to actually like build levels. I could actually look at using tiled. Like tiled is a really cool level editor. I could look at generating these randomly. For now, we're just going to have some kind of hard-coded levels, I guess. But yeah, I'm happy that works. I think that's really, really cool, and I think that's going to be easy to extend. So we get a bunch of stuff for free, basically. So like I can come in and draw another tile. I guess I'll stick to like a similar value. I'm going to make that a little bit smaller. So if I come in here and I do like a brick pattern. Oh, what is it? 1, 2, 3. I think you go 4 down for 16 by 16. 1, 2, 3, 4. That makes sense, right? 1, 2, 3, 4. And then 1, 2, 3, 4. You do one at the bottom. You go up here. You go up here. And then you go like here and here. Yeah, that I think is how you like. I think that's how you brick. This should probably be a little bit different. Oh, thank you very much. Let's maybe do the like little cracky thing there. Just a couple of like little, well, we don't want to get too crazy. But then we'll have, you know, like a cracked variant that has a bit more like garbage in it. A little bit noisy, a little bit of extra detail that's not as bright. You know, it's kind of like a filthy variant of this, right? Let's make that light as well. I don't know if this is really going to be any good, but, you know. And then maybe we do like a grassy version of this. Ooh, was that too ambitious? Well, but again, my thought is kind of maybe you could have like, so down here, right? So I've reserved this bottom layer, and maybe this bottom layer can be something that doesn't have the color blended with it. So like you can have, this is a horrible color, but you know, you could have like a mossy variant, not to rip off of Minecraft too much, but you know, something that like just looks a little bit dirty, right? But then you could, what am I? Right, so you've got like a, oh, I need something over here. I need some more balance in this. I'm really bad at balancing repeating tiles. I need to get a sprite going. So you've got this, right? But then what if, what's the best way to do this? I guess magic wand it, but I need to erase first. That's not what I want. Right, you come in, you get rid of everything that, hold on, I think I'm selecting by hue. Let's go select by composite. No feathering, no anti-aliasing. There we go. So the idea could be that like you have these, it's not what I want, kind of overlays, right? So because of the way the color blending works, if you change the color of this, if you blend it with like red, it'll look like absolute garbage, but then you could have any tile in this row and you could apply this over the top after the color's been done, just as at a neutral color, and it'll make it like another variant of this. So you'll get something else again, right? Another variant again. I don't know. This is my crazy thinking, right? This is my ambitious brain. So, you know, like you can just apply it over the top, right? It's a mask. I think that's fun. I think that's a fun idea, and I'm going to save that. I'm going to export this. Export it to tiles. We're going to export you top left, and then I can come in here and I can go, okay, well, we've added 3 more tiles, so now we can go up to 5, which is, so we can go up to 24, right? Nice. Oh, look at these are gorgeous. These are, I mean, they're not, I mean, gorgeous is a strong word, okay? But they're brick textures. The cracked one looks terrible. It looks awful. I hate it. But you know, we're getting something that's actually drawing to the screen here. It's looking more impressive. It's looking more impressive. And so now, well, we should commit this first of all. I'm trying to be better with commits. So git add. I need to start having more git discipline here, but we're just gonna roll for now. Oh, also, hold on. Resource manager. It's not really a manager. It's kind of the dumbest possible manager you could imagine, but it's a resource resource thingo. Okay. My hair is trying to like take over here. It's very alarming. Okay, so if we go into the right window first of all, we go into resource, and maybe we do like a bit of a, if I just jump over, if we do like a v-split with engine, no, what is it, script resource.fennel, just so I can copy these player frames over, and maybe, I think it'll be less effort to just type them out again. There might be a smart way to do it, I don't know. So res.2uv, it's going to be 0, 0, 16, 16, 256, 64. Oh boy, are you excited about this? I'm excited about this. And maybe I can actually make a short version of this. Let's say maybe function uv x, y, width, height, or just x, y even, right? No, these aren't uniform. My player one is, but okay, no, yeah, let's do this. Let's do this. Hold on. This is gonna be cute. Res.2uv x, y, 16, 16, 256, 64, right? So we're just making a small wrapper function that's gonna clean this up a little. uv 0, 0, 0, 16, 16, 6, no, yeah, 0, 0, because there's a repeating frame in here, and then 0, 32. This is just how we've like encoded our player frames to work. So left is going to be the same, but with the first row of zeros changed to 16s, so we can actually use a find and replace here, I think. Yeah, look at that. That's beautiful. That is a thing of beauty. Power of Vim. Similar thing here with right. We can just change the first row, and we'll get the same thing again with up. Okay, so you're going to get changed to 16s go to 32s, and here 16s go to 48s. See, whoa, that was not the selection I wanted. 16s go to 48s. Okay, perfect. So we've got our player frames. We're gonna need somewhere to actually like drive these animations, but I think we're doing okay. So, player frames handled. They're under control. So now if we go into player.lure, instead of, where is it? Draw. Instead of this, we're gonna go d2d sprite self.x minus cam.x. I really hate that we have to manage this camera offset in every entity, but I really can't think of a better way other than maybe having an overridden, or having like a Draw2D API compatible module that just automatically does the translation. I don't know. That actually doesn't sound too bad. That's how I did it in Fennel, right? You would import camera 2D or draw camera or something instead of just draw 2D. All camera 2D did was understand that there was a camera and apply an offset to every X and Y point that was drawn through it. It was just kind of like a transparent overlay to these APIs. So self.width, self.height. This player is a different width and height than the actual sprite. I would like to redraw the player sprite to be bigger at some point, but we'll roll with this for now. We also need the UVs. So let's set the frame in our update logic, I guess. Frame equals r.player_frames.down 1. Right, the first part of the player walking down animation. Res player frames down 1, yeah, cool. So resource singular. Everything's singular. All my package names are singular. self.frame.uv.u1, self.frame.v1, self.frame.u2, self.frame.v2. Perfect. So now if we draw, attempted to index value nil, that's because we're not passing a texture in. r.characters, I think is what I called it. Nah, nil value. Okay, that's cool. Again, I just called it singular car and singular tile. Everything's singular. Everything's singular. Okay, there we go. We've got a really janky looking player. Really does not look good against a black background. I think it might look a little bit nicer in the PS2 emulator. Let's see. Oh god, it's chugging. He's a little bit wobbly. I don't know why he's so wibbly wobbly. Like, look at this. He's like, the pixels are all kind of like bleedy. It's weird, right? He's a real blobby man. Okay, we need to go back into this main because holy shit, we can't draw this many tiles. Let's go like 3 by 3, right? 9 tiles. That's a sensible amount of tiles. We should be able to handle that. If we can't handle this, we've got a much bigger problem. Okay, there we go. So we can move around, we can attack. That's pretty cool. We don't want to be bright purple like this. That is a little bit, it's a little bit too dark, if anything. So let's go maybe, what color do we want to be? Let's go maybe EO. EO FF. Nice blue tint. Okay, that's actually very, very white, but okay. Nice. I mean, this looks cool, right? This works. This actually works. I think there's a trick to getting crispier looking pixel graphics on the PlayStation 2. I just don't know it. Nice. Okay, we got to start building some dungeons. I've got to work out how we're gonna like edit levels. Maybe tiled is worth looking at, right? I know. I think Shovel Knight was built in tiled, right? Editing various projects. Nice. Yeah, this looks quite cool. Tiled. It exports into Lua. Holy shit, I didn't know that. Export into Lua code. Does features. Yeah, we might need something to actually parse it from Lua. I don't know if it'll be a flat list. Yeah, I mean this looks like a pretty good option though. This looks like a pretty good option. Man. extensible as well. So I think, yeah, I can just like add my own custom exporter, which might be what I do. But I don't know long term what my goal will be. Like I said, random levels would kind of be awesome. I just don't know if I'm going to go to that much effort for this game. Also, I'm going to tone these colors down because this is a lot. Let's go back to like maybe 80, 80, 90. Let's go to like a nice blue tint. Yeah, there we go. Slightly blue tint, man. I think that's a lot nicer. Okay, so we have a guy. He can move around. He can attack. But let's think about when we actually change our direction. So when we change our direction, let's say self.frame equals, okay, r.playerFrames.left. We'll do what we didn't actually get done in the game jam. And change the way we face. Are you so ready for this? Okay, it did nothing. It did nothing. I don't know how that did nothing, but it did nothing. All right. I love it. Self to frame. How does this not... Unless I'm building player frames wrong, right? Resource.lure. Okay, how about when we change direction, let's also print self.frame .uv u1 .v1 self.frame .u2 self.frame .v2. Okay, every time we change frame, let's print that out. And we'll run it in the emulator. We'll run it in the emulator. Okay. So these all have the same. UV coordinates. Interestingly, I've got to be doing something wrong here. X Y 16 16 res.2uv. This looks good. This looks good, right? Why is the X not doing the X thing? Why are you not 16 16? Why are you? Because like when I run this, right, it's just like, oh yeah, have I somehow overridden? No. These are, what on earth is happening here? r.playerFrames.down, r.playerFrames.up, r.playerFrames.left, r.playerFrames.right. This is surely what is happening. Am I overriding it? No, I'm not overriding it, because when I print it out, it's wrong. Right? So when I go down, yeah, but when I go right, it's the same thing. There's never update. The X should change. These two columns should change when I do this. I guess I'll add like a printer here just to check that I'm not doing something weird. That's the wrong runner. Okay, where are we? Add player frame. Yeah, so this looks fine, right? This looks fine. Why are they the same? How? What have I done? What have I done here that's so weird? Self-dot frame. Self-dot frame equals. I've got to be like losing my mind here, right? Right? What? Because Oh, I thought I just heard someone knocking at my door, which is very alarming at this time of night. Okay. I think I need to take a quick breather because this is stumping me. Hopefully when I come back I'll have the energy to crack it. Back in a moment. I'm very confused. I'm very confused. I'm missing something really obvious here, surely, right? Right? U1, V1, I'm like... Oh, what? What could be going on? Okay. So look. Here's another thought, okay? Let's start facing up. Let's start facing up and not press any buttons and see what happens. Other than that one. Okay, we crashed. We crashed. We crashed. That's very telling. That's very telling. Let's see what Love 2D says. Oh, Love 2D says we're facing left. And then it never updated. Okay. Okay. Something strange. Something strange has happened. Frame. It's like we're overriding the frame somehow. Is that crazy? Does that... So what if I change this to like left, right? What if I change this to left? Then we start facing up. So first things first, let's just like fix that. So this is up and up is left, I believe. Let's see if this... Yeah, so we're facing left, and then we always face left, no matter what we do. This never updates. But it does update. It updates. Why does this not update? Why does this not do anything? Why? We literally set this and then read it out. So either the whole player frames table is somehow being overridden. Is it correct to access zero? Oh, hold on. Every time. You're absolutely right. I got lured. Thank you so much, Zymus. Every time. Okay, this is gonna work now. This is just gonna work. Yeah, look at this. Okay. The sprite work is terrible, but the fact that we now actually face in a direction as we move, I love it. I love to see it. Thank you so much. Absolute lifesaver. Okay. Self dot frames. Alright. Now we're cooking with gas. So I can't believe how many times in this Lua adventure that has happened to me. Thank you so much. Okay, so let's do the dumb thing first, right? Let's give ourselves an animation timer. And let's set it to 0. And we'll have some like magic constant here, right? So let's say anim time max, maybe. What period does that animation run on? What period does that animation run on? Maybe let's give it like 1.2 seconds. We can tweak it if it's too long. And now this frame becomes, well, we no longer set the frame here, right? We come down here and we say, it depends on our move length. So if move length is greater than 0, then we advance our animation frame. Otherwise we say anim self.anim timer, right? Self.anim timer equals self.anim timer plus dt. And then we come down here and we go, what proportion, what frame are we up to? So, local anim frame. We're going to assume all of our animations are 4 frames long, which is not correct, but we'll go for it. This is also assuming that the only thing we're going to be animating is walking. So this is limited, but workable. So the animation frame is going to be 4 times self.anim timer divided by anim timer max, right? What proportion of the animation are we through multiplied by the number of animation frames? So what frame are we on? So 0, 1, 2, 3, 0, 1, 2... There's someone like downstairs knocking on something, and it is like very alarming when you're just in a house alone at night and you can just hear like a creepy knocking. Oh, it is the worst. I don't know what they're doing down there, but it is very alarming. Okay, so this is going to give us a number 0, 1, 2, 3, but never. Well, it might give us 4. And I think we can actually do like a floating point mod here. So if I go like let's say 0.9 mod 1.2. Okay, maybe no floating point mod. Lua floating point mod? Question mark? Oh, that's because I'm not. This wants you to print. This isn't like a REPL. This is just a rel, right? Read eval loop. There's no print in it for some reason. 0.9 mod 1.2. Yeah, and so if I go to like 3.7, yeah, look at that. Okay. Oh my, this, I don't know if that knocking is picking up on my microphone, but it is so alarming. Timer max. Okay, here we go. So what frame are we on? And then we grab a frame. So let's go local anim dir equals so if our direction is left, then anim dir equals r.playerFrames.left. Else if self.dir is pad right, then anim dir is r.playerFrames.right. Else if self.dir is pad up, then anim dir is r.playerFrames.up. Else, and we're deliberately leaving the down case till the end because this is going to be our like default, because it's a nice safe neutral direction, right? Down, it's kind of the default pose for the character, I think. And then we say self.frame equals anim dir anim frame plus 1, and now we're going to get a nice animation. There's going to be no syntax errors. It's going to be a few syntax errors, just because I forgot my commas. Okay, anim timer, anim time max, anim timer max. Thank you very much. Let's be consistent with our names. Okay, we've got a weird little twitchy. Okay, hold on. We've got a few logic errors here. Okay, that's how it goes. So, setting our direction works correctly, right? We know because we check it here, right? So we have an animation direction. Oh, yeah, right, up, down. Anim frame is. Okay, what if for simplicity's sake we just set the anim frame always to 0? Then we should just get our directions, and we don't. Okay, that's good to know, right? That's really good to know, because that means that that helps us hone in on where our logic has gone wrong, right? Stuff.dir. We're reusing our pad input enumeration, right, for direction, because I think that's just as a good convenience. It's already there. We already have these like 4 directional constants. We may as well reuse them. Oh, hold on, pad dollar. What am I doing? Don't there we go. I was gonna say don't drink and code. I haven't even been drinking. I'm not even allowed to drink. Okay, we're moonwalking. Okay, so the actual like direction works, but the animation's weird. Okay, hold on. This should work, right? Because we're getting the the time through the animation, right? Does that make sense? That makes sense to me. Okay, so first off, why does this always... Why when we're animating do we always face the same direction? That's weird. That's weird. Alright, well let's do our old favorite and say print anim frame. But let's do this on the PS2 because we get better logging. Okay. So this looks correct, right? We're getting these... Oh, hold on. Hold on a minute. I've got you worked out. You can't take a float index here. It has to be math.floored. There you go. That'll do it. Like, this knocking. If you want to drive your downstairs neighbor crazy... Oh, here we go. He's walking. Do you like my high quality pixel art? It's kind of cool. I actually like that if he's taking a step as you turn, he remains taking a step. Okay, so this is primitive, right? This is primitive, but it makes the game look a lot more charming. Definitely makes the game look a lot more charming. Look at this. Look at him go. I'll have to find someone to like redraw this pixel art for me. It's pretty terrible. I know a guy. Oh, that makes me really happy to see. Okay, beautiful, beautiful. So we have exceeded our original spec, our original Game Jam game. Git commit. Perfect. What am? Oh, that's really not what I wanted to do. That just closed. Cool. Closed many things. What have I got up over here? Why do I have this up over here? Oh, hold on. I've just got this tagged twice. Okay. Okay, we're good, we're good. First time I've closed Vim this whole stream. Yeah, Zymus. Absolute legend. Great. Great to have someone to just like check over my shoulder. Okay, so. Let's have a look at how I implemented the bat. I was actually really happy with the bat behavior. I think this was potentially the highlight of my Game Jam entry, right? I was really, really happy with this little state machine that ran in the bat. It's pretty simple, right? So it has an animation timer, actually fairly similar concept to what we have in the player just now. It has a little wait timer for when it first spawns so that it doesn't kind of jump into action. It does a few things every time it updates. First, it checks if it was hurt. If it was hurt, it updates its state to a running away state where it tries to distance itself from the player. Otherwise, it grabs a reference to the player, makes sure that it isn't nil. If it's nil, then we're just going to like do some, I think nothing, in fact. We're going to work out the distance to the player and how fast we want to be going, and then we're gonna... There are two kinds of behavior. There's move seek, where we try and close distance to the player, and there's move strafe, where we try and circle the player. And this actually ends up having a really dynamic feel to it, right? Bats try and close distance, then circle around you, and then you hit one and they back off, and then they circle around and move back in, and it gets very chaotic very quickly, in my opinion. And yeah, like these bats kind of cycle through states as well in order. Or at least, you know, cycle between like two states, right? There are 3 states, but they cycle between 2 states, I guess, when they increment state. So this is state 1 and this is state 0, I think. So you always go from strafe to seek. Oh no, sorry, this is state 0, this is state 1. So you always go from seek to strafe, and then this is state 2, so when you add 1 to this, you get 1 mod 2, so you go from flee to strafe as well. So they kind of like link together through this one really simple maths operation. So we have most of the machinery we would need for this. Let's go e script bat.fnl, and I'm gonna have less structure in, not fennel, sorry, lure, less structure in my folder hierarchies, because that will become a problem if I ever want to put this on a disk. Okay, so, local bat. We need our default table here, so we're going to have a width of whatever we had here. What are our defaults? Where are our defaults? Entity. One of the weird things about this version is that I had all of my entities defined in this table here, which kind of sucked. Okay, so bat.lure 28 by 14. 28 height equals 14. And then, yeah, well, let's have a type of enemy. And then it needs, yeah, draw an update function, but that's all good. Let's check our player and see if there's anything else interesting. We should give it a Vx and Vy as well. Vx equals 0, Vy equals 0. So we can keep track of how fast we're going. Let's space this out nicely as well. Make everything nice. Make everything nice. I don't have a lure linter installed, so we're gonna go nice. Walk. So yeah, we'll go speed equals 56, and state equals state. Or state equals seek. Well, let's have a wander state as well. Aimless state, I guess, that's quite good. And then say state timer equals 0.2. So the idea is that we'll do something just for a quick second before we lock onto the player. So it's a little bit less jarring the second you come into the room. So let's have some kind of constants for our states. And the way we define these is going to be important as well. So seek is going to be 0. Strafe is going to be 1. No. Seek is going to be 1, strafe is going to be 0. No. Seek is going to be 0, strafe is going to be 1, yeah. And then flee is going to be 2. Because we're going to do this same add 1 mod 2 thing. So flee always maps to strafe, and aimless always maps to seek, right? But seek and strafe never map out to flee and aimless directly just through advancing in the state machine, as a special event has to trigger one of these two. That's going to be our goal. And so aimless is going to be triggered by not having a target, or by having just spawned, and flee is going to be triggered by taking damage, which I actually don't think will be possible at the moment because we don't have collisions yet. So let's go function bat.draw. Oh, it's going to take in a camera, of course. And let's copy the draw function pretty exactly from the old bat. Draw. Yeah, cool. Just 80, 80, 80. Then we're going to say D2D sprite. Now we need to add another set of frames here. So let's say bat frames. And this actually isn't going to have a direction. This is just going to be 2 frames. This is going to have well, we're going to redefine this UV function. I think this is a good pattern. I think this is a crappy pattern, but an acceptable one, because this bat's going to have different dimensions, right? So if we go into resource.fennel, we can have a look at the bat, and it's 28 by 14, as you would probably expect. 28 by 14, because that was the width and height we just defined in the entity. So 28 by 14, the bat frames are going to be 64 by 24, and was that 92 by 24? 92 by 24. Cool. Alright, so we have bat frames. We're going to draw it at self.x, self.cam.x minus, no, self.x minus cam.x. Y minus cam.y. We're going to give it a width of 28 by 14, and then it's going to be at self.frame u1 I feel like we're starting to see like a bit of a pattern with this like the player has a frame that it just draws from, the bat has a frame that it just draws from. I feel like we might be able to generalize this, but also it might be too little to generalize. Like, I don't know, that may not really be worthwhile. So let's say frame equals r.batFrames1. 1, not 2. DT, and then also the state. We need the state reference because we need to be able to get the target. We need to be able to look up the player. Okay, so if I spawn oh, hold on, I'm missing one thing here, which is going to be two things here, which is going to be the resource and the draw2d modules. So local d2d equals require draw2d, and then we're going to do the same thing for resource. Cool. So now if I go into main, not that main, the other main, we're going to define our bat. And I might define a few different bats eventually. Like I think in my fennel code I called this bat1 rather than just bat. With the idea being that you could have like bat2, which is maybe like a slightly red tinted bat that moves a bit faster and maybe like has less time strafing and more time seeking, or, you know, just kind of has like a few different numbers but is the same behavior. But anyway, we also need to actually like include this bat. And this main function is getting really great, so we need to do something about this initialization as well. But for now, it'll be okay. Okay, now we're gonna spawn an instance of the bat. We're gonna spawn it at maybe like 400. Let's spawn him a fair distance away and let's see what happens. Yeah, this is okay. Bat. This is just because I missed a comma, and then I also need to return bat. Always remember to return your bat, right? Don't have an overdue bat. I can hear some faint music in the distance. Okay. Expected to close. 26, 26. I've missed a comma. Nice. There's our bat. There he is. My graphics are not great, okay? But it's something. I tried really hard. Okay, well, let's give the bat a little bit of behavior. I may not do the full state machine, but let's give him a little bit of behavior. Okay, so let's go local equals equals. Now, how do we look something up in our state? Game.lure. Okay, hold on. Let's say if self.target is nil, then we're going to want to look this up once. So find player. If target's nil and self isn't aimless. So we want to look for a player if we're not just like aimlessly wandering around. That's cool. And then we come down here. If we haven't found a player, then we set our state to aimless. And we set our state timer to like, I don't know, some magic number. Let's look every second, right? That makes sense. Okay, otherwise, if self.state is aimless, then okay, so aimless kind of just has its own thing, right? We don't have a player target. We just wander around and don't really care about anything. Otherwise, we actually want to like get our distance. So let's say d equals, okay. We've got to do some vector stuff. So what do these APIs look like again? We're going to copy examples from our player. Impulse length, yeah, impulse is a vector. Okay, so it's going to be vec2 self.x minus player.x, right? Self.x minus self.target.x, self.y minus self.target.y. And then normalized. Did I stop normalizing this? Vector normalize, not normalized, no plurals. Okay, or no past tense, I should say, only present. Okay, so if self.state equals seek, then move seek d. Else, it's got to be self move seek. We'll give it, yeah, we'll just do that for now. Else self.state equals strafe, then self move strafe. Else self. Oh, hold on. No, I can be smart here, right? So we have a speed. So we're gonna seek self.speed. So we move in towards the player at a certain speed. Otherwise, we strafe. We'll pass in a speed to this as well. We'll strafe at a slightly slower speed. But if we're fleeing, then we actually just call move seek again, but we multiply our speed by a negative number. So we move away from the player rather than towards them. Else. Now let's not crash the game for it. Bat in unknown state, and the state is going to be self.state, and then we're going to say self.state equals aimless. Perfect. Now we advance the state machine, right? So self.state timer equals self.state timer plus dt. If minus dt, we count down. So if self.state timer less than or equal to 0, then self.state equals self.state plus 1 mod where did I go? Plus 1 mod 2. Perfect. And this is beautiful. And then our state timer goes to like some number. State timer equals 0.9 maybe. I like that. Okay. So this means that, yeah, we have got this like really simple state mapping. We've got a few really simple behaviors that we need to implement. So move aimless is going to be easy, right? Move aimless is going to be easy. Function bat move aimless. And that's not even going to take a speed. Let's say self.vx equals 4. Let's say we'll just move to the right a little bit, right? 4 pixels per second. No, we need to go a little bit faster. Let's go 10 pixels per second. Function bat move seek, and this takes a direction and a speed. This takes a direction and a speed. Okay, so what we're going to do, we're going to say self.vx equals, well, we're going to say d.scale v d.x self.vy equals d.y. That's simple, right? There's nothing fancy going in here. And then function bat move strafe. Now here we go. This is where it gets more interesting, and there's some good logic here I wanna copy, right? So distance. Ooh, I got this as a, oh yeah, I've got to pass this not normalized so that I can like rotate in a circle around the player, right? Otherwise, maybe I just like don't work this out here, right? Maybe I just forget that. Let's forget that. Okay. what we're gonna pass, we're not gonna pass in, we're just gonna pass in a speed. We're just gonna pass in a speed. So we're gonna say, we need to actually work out this d now. Local d equals v.vec2 self.tgt.x minus self.x, self.tgt.y minus self.y, d normalize scale. That easy. So now, whereas here we go d equals we don't normalize. We use this at its full length because then we work out this arc x and arc y. Okay, so let's and actually let's forget vx and vy. No, hold on. Yeah, okay. We got this. V is pre-multiplied by dt in this case. That's the other thing I'm missing, but we'll get back to that in a second. That's not super important right now. Okay, so let's say local arc x equals tx. Where did tx come from? Move strafe, target x, target y. Okay. So equals self.target.x plus d dot. Wait, what's v? God, I've called my variables different things. That's very confusing. Okay, yeah. So this is d dot x times math.cos 0.01, just some like arbitrarily small angle in radians, and then we're also multiplying. No, we're subtracting. Okay, yeah. God, this is hard to like convert to what's it called? Infix. Math.sin 0.01. Yeah, there we go. Subtract these things and add this on, and that is your magic arc value, I think. Okay, and then we do the same thing to get an arc y, except we flip things around. So yeah, y plus x times sine minus y times math.cos. And we normalize. Yeah, okay, so let's go move equals v.vec2. We're gonna say my arc x minus self.x, arc y minus self.y, and then move scale the move normalize move scale v, and then we self.x self.x equals self.x plus move.x, and then we do the same thing. My word, what a hassle. Okay, so if I lint this, I'm guessing it's gonna fail. Yeah, 63 self. Missed a comma. I'm thinking too much about Lisp. Does this work? No, local speed and nil value. Okay, that is because I've forgotten to dot a speed somewhere. Speed. speed. Oh, it's because I didn't pass an argument in. Yeah, so I need to scale these self dot. Let's just give it a nice slow speed. We have to multiply by dt out here because we don't want to pass dt in. You know, dt lives out here. The movement logic doesn't care that there's a delta time. Okay, index global v and nil value. We haven't included vector. That's fine. S and nil value. Oh, hold on. So where's it failing? Vector 18. Scale. There's a scale that it's not liking. And apparently I'm calling scale without a value. So one of these functions. Oh, right, because I'm no longer... Yeah, I'm only passing one argument into them now, so that argument was nil. Here we go. Oh, where are you going? Okay, this isn't quite perfect. Okay, I think the circle logic might have some problems. Oh no, it looks like the circle's actually kind of working. It actually looks like he's hitting statefully. So this should never get printed, right? Let's see how this goes on the emulator though. It's kind of cool. So he closes in. And then he just goes away. Interesting. I mean, it's pretty erratic behavior. I don't hate it. But it's obviously not quite what I want it to do. I don't want my enemies to just seem this aimless. Oh, this is just feeling so crispy and smooth. I really like it. And then, of course, we actually have no collision. So we have a bat that kind of works. Oh, I forgot to check my logs. Damn. Let's just quickly... Actually, no. When we change state, let's just kind of print self.state. Bat to... Okay, so let's keep track of what our bat's thinking, right? Let's get inside the head of the bat. Become the bat. Bat to 0, bat to 1, bat to 0, bat to 1. Okay, so have I actually done this in the wrong order? I meant to... Is it self... my position minus the player's position, and then I move to what? Have I done this backwards? Have I done this backwards? I don't think so. Let's swap it and see what happens. And a self.target.x. The other thing is I might have just like not changed an x to a y somewhere. Self.target.y. I don't think this really makes much sense, but let's see what happens. Yeah, then he's just like gone, right? Okay, and actually, hold on. If I think about this, if I really think about this, all the weird behavior comes 0, 1, 0. I don't know, both states have really weird tracking of our target. Sort of target at x, sort of x, sort of target y. Weird. Very, very weird. Very, very weird. And this is 0, this is 1. So seek is 0, strafe is 1. But then why sometimes is seek moving away? Why is seek moving away? 0, negative, positive. Self.y plus d.y. That's all good. I had some issues in the game jam where I was like doing plus d.x here, and I was like, why is this moving so weirdly? That was a bad time. That was a bad... Oh. Yeah, no, this is fine, right? We want x times sine minus y times cos, x cos y. This is like... This makes sense. Self.target.y, self.y plus. So what are we doing here? What are we doing? We're getting the distance from, or like the vector from the target to ourselves, right? So we're taking that offset, that. So we're taking that as the radius. So we're taking that as like, yeah, the radius of a circle, right? We're multiplying the x components and the y components by circly things. We're adding them back onto this. And then, why do we subtract here? Arc x. How far do we have to move to get to that point around the circle? X is such x, y, so move to y. Let's stay in one state for longer. Let's see what that does to the bat. Okay, because if we run this now, we expect the bat to be able to come pretty close to us, right? Bat goes to 0. Oh wait, he's following this. Wait, he is on a different planet. Hold on. I think I see what's happened. If I go to script main, right? If I find this test entity, I gave him the type of frickin' player. That explains a lot. Okay. Let's get rid of this frickin' test entity. Holy shit, he wasn't even following me that whole time. So now this bat follows me, right? And now he should be like strafing around me. Okay, so the strafe doesn't work. I mean, it kind of does. It works in that he maintains a distance from me, right? Or he... Okay, he can only move. He only has movement on the x-axis, but that's a start. Okay, well this test entity has outserved its purpose. Thank you very much for the follow, Dimitri Maximov Galahad. Sorry, that's a very long name. It's very hard for my brain to process. I think you have jumped in right as I'm about to finish up, unfortunately, but I do really appreciate the follow. Look at this. We've got a boy animating. We've got a bat that almost works, right? I feel like if the Y was working, this would actually be fine. We've got our multicolored tiles that are kind of crappy. I don't know what I'm going to do about the pixel art in this game, but I'm going to try and make it better. And next time it's collision. We're going to get this happening. We're going to get these things colliding. We're going to make sure that we can't just move through walls and phase, like, you know, through the very fabric of the universe. I might spend some time off camera with the tiled level editor as well, see if I can get a workflow working where I can import things, because I had a level editor working for the Game Jam, right? I spent a bunch of time in the Game Jam building a level editor, and then when I tried to import levels into the PlayStation 2, it just crashed the PlayStation 2 every single time. So I'm probably going to finish up there. I might give this a quick run on my PlayStation 2, make sure it works. Thank you very much for tuning in. Thank you to everyone, once again, who has been watching on YouTube. It's awesome that people have been finding my videos, because, as I've said many times, I'm not actually advertising them anywhere. So thank you all very much for tuning in. Thank you to Zymus for pointing out that I was messing up my my Lua list indexing again. That was a bit of egg on my face. I've been Tom, and I'll hopefully catch you all next time.